Okay, so number 2, 6x squared plus 7x minus 3 equals 0. So you have to move the 3 over, get it set equal to 0. Factor. 6x squared could be 6x and 1x. Most likely, though, 3x and 2x. So I would start with that first. I want the 1 here and the 3 here. 1 and 3 are the only things that are going to multiply to 3. I have to check then my outers and inners. 9x and 2x will add to 7 if I make the 9 positive and the 2 part negative. And notice the last do give me -3, which is what I want. I want them to multiply to a -3. So you get your firsts set up, your last set up, and then you make sure the outers and inners add to the middle. All right, 3x minus 1 equals 0, so x is a third. 2x plus 3 equals 0, which means x is -3/2. So those are your answers. Nothing to reject with a quadratic. When you're doing the square root method, then you are going to just isolate the square, divide by 3. X squared is 9. Square root, when you square root in an equation, you need plus or minus. So don't forget that. This next one, if I'm going to solve by completing the square, I'd have to divide by 2 first. The reason being, the completing the square method has to be, it can only be done if the leading coefficient is a 1. And then you group the x and the x squared, move the constant over, go off to the side. You're going to take half of the b. Half of -3/2 is -3/4. Square it, you get 9/16. 9/16 then is what you would add to both sides. Now on this side, half the b is going to go in the parenthesis, which we figured out right here. On the other side, I'd have to have a common denominator. So remember, I've talked about the importance of knowing things without a calculator. So you should be able to add your fractions without a calculator. Then square root x minus 3/4 equals plus or minus. Square root of 16 just gets written radical 6, or I'm sorry, square root of 17 gets written radical 17. Square root of 16 is 4. And then move the 3/4 over. So standard form is to write the radical part second. Number 8, quadratic formula. I'm going to come over here. So in 8, first of all, I have to write it 3x squared minus 6x minus 5 equals 0. Get everything to one side. A is 3, B is -6, C is -5. So it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals, okay, so this would be 36 plus, because minus is plus. Let's see, 20 times 3 is 60. So this is 6 plus or minus square root of 96 over 6. That's 6 plus or minus. Now, radical 96 gets broken into radical 16, radical 6. So that's 4 radical 6 over 6. And then remember, you have to So 4, 6, and 6, you can take out a factor of 2. So you're going to take a 2 out of here, get 2, 2 out of here, get 3, 2 out of here, get 3. So your answer is x equals 3 plus or minus 2 radical 6 over 3. You cannot just slash those 3's out. Sometimes people want to slash the 3's. But no, the 2 radical 6 also has to get divided by 3. So you do not want to slash the 3's. 10, that would be bringing this over and then just calculate zeros from your calculator. But what you're actually going to see, this one is unique in that when you graph it, it's going to look like this. So where does this thing equal 0? Where does y, because we're putting this in for y, where does y equal 0? Well, nowhere. It doesn't cross the x-axis, so no solution is the answer to that one. For 12, this is an inequality degree 2. That means you must partition the number line. So we have to factor. On our number line, we put what makes our factors 0, which should be -1 and 4. Open circle, because it doesn't say equal to 0. Those are the values where it would equal 0. This doesn't equal 0. We want to know where it's less than 0. And then I would put my factors down in partition. So I pick a number to the left of -1. So over here in, this part of the number line. I don't know if I want that as the answer though, but I'm going to pick something from over there. So like -2 would make that negative. -2 would make that negative. That's overall positive. In between -1 and 4, I'd pick something like maybe 0. Anytime I can pick 0, I pick that. 0 minus 4 is negative. 0 plus 1 is positive. Overall, that's a negative. And then finally, to the right of 4, I pick 5. That'd be plus. That would be plus, which is overall plus. Less than 0 means so since this says less than, I want the negative. So I'd say -1 to 4 would be my answer. 14. I can go right to the number line since it's factored for me. -6, -4, 2. Closed circles, because it does say equals 0. I put the x minus 2, the x plus 4, the x plus 6. I go through in our partition. So I pick a number to the left of -6, like -7. That would make that negative, 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 which is overall negative. In between -4 and -6, I pick -5. That would be negative, -5. This would be negative, -5. The third factor would be positive, because -5 plus 6 is a positive. Overall, that's positive, because 2 negatives make a positive. In between -4 and 2, I'd pick 0. So that's minus, plus, plus, which is overall a minus. To the right of 2, I pick 3, plus, plus, plus. Okay, now the original problem says less than or equal to 0. Less than 0 is the negatives. The equal to we already took care of with the closed circles. So my answer here is -infinity to -6, hard bracket, -4 to 2. Um, 16, absolute value equation. Isolate the absolute value. And then we're going to separate this to 2x minus 1 could be 2. 2x minus 1 could be negative 2. So 2x equals 3. X is 3 halves. 2x equals negative 1. X is negative 1 half. So 3 halves, negative 1 half are your answers. Now with an inequality, remember less than or equal to, like we have here, is the one that you kind of sandwich in the middle of the negative 7 and 7. And then you are simultaneously solving two inequalities at the same time. So minus 5, minus 5. Then you're going to divide by 2. Oops. All right, so it'd be negative 6 less than or equal to x less than or equal to 1, which means my answer is from negative 6 to 1. For 20, I have to factor here. Let's see, 4, 1, plus, minus. So x plus 4 and x minus 1 are my least common denominator. So I'm going to multiply this by x plus 4, x minus 1, this x plus 4, x minus 1, this x plus 4, x minus 1. All right, so here I have 4x times x minus 1, plus here I have 3 times x plus 4. Since it's following a plus sign, I don't have to really worry too much. There, that all cancels, so I just have 15. Okay, so it's 4x squared minus 4x plus 3x plus 12 equals 15. That's just doing my distributing. This is 4x squared minus x. It's combining those two. I might as well minus the 15, so then that'd be minus 3 equals 0. So now I can factor. Now in this case, normally with 4x squared, I'd maybe do 2 and 2. I'm going to do 4x and 1x though, because that's what's going to work with the 3 and the 1, so that my outers and inners can give me a negative 1. They can give me the middle here. So negative 4 plus 3. Notice my lasts give me negative 3, which is what I want the last to give me. So x is negative 3/4, and x is 1. However, because of the denominator of the fraction, I can't have 1, so I'm just going to keep the negative 3/4. Next one, you would have to graph. You'd have to calculate zeros, which should be approximately negative 2.82, negative 0.34, and 3.15. So what this looks like, right about here, it is equal to, so I'm going to color that in. So negative 2.8, negative 0.34, and 3.15. There are zeros. And then the graph, looks somewhat like this. So to the left of negative 2.82, notice how my y's are below the x-axis. So this is where it would be less than 0. This is where we have the negatives. Also in here is where y is negative. So remember, you would take x to the third minus 9x minus 3 less than or equal 0. We're putting this in the calculator for y. So we want to know where the y is less than or equal to 0. Well, they're less than 0 where it dips below the x-axis, right? These are negative y values. These are negative y values. So over this interval, my answer would be negative infinity to negative 2.82, hard bracket. And then negative 0.34 to 3.15. Uh, 24 is a little tricky. You would first have to move that negative radical over. Now, once you do that step, it follows just like the other problem in that you are going to square both sides, which will get rid of the radical on the left. It will not get rid of the radical on the right. You'll have to write that one out twice. And FOIL. First, give me 4. Outers, inners, give me a 4 radical x minus 1. Last, give me the x minus 1. 4 minus 1 is 3. So 3 plus x plus 4 radical x minus 1. Okay, so minus 3, minus 3, minus x, 2x minus 2 equals 4 radical x minus 1. Just to show you here, if I look at the 2x, the 2, and the 4, I could choose to divide by 2 on both sides. It's almost like taking out, what the GCF would be. And that will just enable me to have smaller numbers to work with. So now, if I square both sides, right, I wouldn't want to divide by 4 because then I'd have fractions on the left-hand side. So that's why I just divided by 2. So I didn't have any fractions. Now I'm going to square both sides. 2 squared is 4. The radical squared is x minus 1. So this is x squared minus 2x plus 1 equals 4x minus 4. Move everything to one side. What we'd subtract the 4x. So that'd give me a negative 6x. And we'd add 4. So that'd give me plus 5 equals 0. Factor. So I need 5 and 1 is the only thing that's going to multiply to 5. And they need to both be negative so that they add to negative 6 but multiply to positive 5. So we get x equals 5, x equals 1. If you check those, what you're going to see is they both work. So remember, with radical equations, you do need to check for an extraneous root. All right, and last question, we're going to look at the box problem. So remember, we're starting with an open top, or we're starting with a piece of cardboard that's 18 by 14. We are going to cut out square corners. We don't know the dimensions, so we're calling them x by x corners. We're going to fold that into an open top box. So the new length, or the length of the box, is 18 minus 2x. It was 18, but we cut off x and x. This then is 14 minus 2x, and the height of the box is x. So an equation that represents the volume is x times 14 minus 2x times 18 minus 2x. Those can really be in any order because multiplication is commutative. The domain of the problem is always between 0 and half the shortest side of the cardboard, which is 14. Half of 14 is 7, right? So it's between 0 and 7. What size corner to the nearest hundredth should be cut to yield a volume of 100? That's going to be a y equals 100 line, and then calculate intersection. Okay, so that's what you're, just to kind of give you an idea of what you're going to do there. So y equals 100 line, then calculate the intersection. These two, you're going to have to calculate the max. What size corner, that will be x value of max, right? Because the size of the corner that we're cutting is x by x. What is the maximum volume? That'll be y value of the max. So you have to calculate the max with your calculator. If you're having any trouble with those, you can ask in class. Okay, that's it for even.